Hello class, today we're going to talk about section 8.3, graphs of exponential functions. Our learning target today is to be able to graph an exponential function. That's what we'll be able to by the end of today. First thing we want to do is define an exponential function. So an exponential function is a function of the form y is equal to a times b raised to the power of x. Now let's talk a little bit more about that. So we define an exponential function as y is equal to a times b to the power of x. Now that b value is what we really want to focus on. Okay? That b value is what we want to focus on. Whatever number is being raised to our x variable. Okay? Now, if that value b, I should say if the absolute value of b is greater than 1, we will see exponential growth. If the absolute value of b is less than 1, we will see exponential decay. And we will see what both of those look like in just a moment. Okay? And if the absolute value of b is equal to 1, it's not an exponential function. Okay, so not exponential. Alright, so again, we really want to focus on that b value, whatever's being raised to our power of x. If that absolute value of b is greater than 1, we have growth. If the absolute value of b is less than 1, we have decay. And if the absolute value of b is equal to 1, it's not an exponential function. Let's see what these look like. So let's start with one that shows exponential growth. So our first function we have here that I'm going to display it is y is equal to 3 to the power of x. So in this case our a would just be 1 times 3. But let's see what that graph looks like. Looks like this. So again, we see exponential growth, okay? This keeps growing forever and ever and ever and ever, okay? On this side, it gets infinitely close to the x-axis, but it never actually touches. And we see this exponential growth, all right? That's what happens when our b value, in this case 3, is greater than 1. What if our b value is less than 1? So for the second function, we have y is equal to 2 times 1/2 raised to the power of x. And as you can see, the number being raised to the power of x, in this case, is less than 1. So let's see what the graph looks like. Looks like this. Now this is showing exponential decay. So we're getting smaller and smaller and smaller. Now, the interesting thing about this is it never actually touches the x-axis. So the y value is never actually 1, it just gets infinitely close. I'm sorry, the y value is never actually 0, it just gets infinitely close to that axis. So as you can see, we have generally the same shape, just going different ways. Alright? The red one is when we have exponential growth, when our b value is greater than 1. The blue one is when we have exponential decay, when our b value is less than 1. Let's see how we're going to go about graphing these. So let's start with example 1. We want to graph the function y is equal to 3 to the power of x. What we're going to do is we're going to make a table of values. And for these table of values, we're always going to use the same values of x. -2, -1, 0, 1, and 2. This will give us a good shape in order to graph our function. So what we need to do is we need to plug in those values of x into our function. So for my first value, 3 to the power of x, we plug in y is equal to 3 to the power of -2. 3 to the power of -2. Again, when we have a negative exponent, we know we're in the wrong spot, so we're going to put that into the denominator. we end up with y is equal to 1 over 9. Then we do the same thing for the rest of these x values. 3 to the power of negative 1 is 1 over 3 to the power of 1, or 1 over 3. 3 to the power of 0, any number raised to the power of 0 equals 1. 3 to the first power is 3, 3 to the second power is 9. So here we have some ordered pairs. Our first ordered pair is negative 2, 1/9. Our second ordered pair is negative 1, 1/3. Our third ordered pair is 0, 1. Our fourth ordered pair is 1, 3. And our last one, 2, 9. So what we need to do now is just graph those ordered pairs, okay? So we're going to draw a coordinate plane and plot the 5 points. Then we're going to draw a curve through the points. All right, let's go ahead and do that. So negative 2, 1/9. How do I graph 1/9? Just go somewhere in between 0 and 1. This one's going to be closer to 0. Negative 1, 1/3. Again, how do you graph 1/3? Just in between 0 and 1, a little closer to 0. 0, 1. 1, 3. And 2, 9. All right? And as you can kind of see here, we have that curve up peg. A little something like that. And we have graphed this exponential function. All right? Notice that the graph has a y-intercept of 1. Okay? Has a y-intercept of 1. And that it gets closer to the negative side of the x-axis as x values decrease. Not much room here. Great. So we just graphed an exponential function. This one is showing exponential growth. So what we did, we created a table of values. We always use the x values of negative 2, negative 1, 0, 1, and 2. At least for the ones we'll be doing. Get our ordered pairs, plot our ordered pairs, and draw the curve through. Let's take a look at the next example. Example 2. In example 2, we are going to graph the exponential function y is equal to 2 times 1/2 to the x power. Now, what you should notice here is my b value, the number that's being raised to that power of x, is less than 1, meaning we're going to be showing exponential decay, something like that. All right? Same idea. Let's do a table of values. Now, these ones are going to be a little bit tougher, okay? These ones are going to be a little bit tougher because we have y is equal to 2 times the power, 2 times the value 1/2 raised to the power of x. So if we start with 2 times 1/2 to the power of negative 2, we need to be sure to follow order of operations, okay? We need to be sure to follow order of operations. If you plug into your calculator 1/2 raised to the power of negative 2, you'll end up with 4. And then 2 times 4 is 8. So when x is negative 2, y is 8. When x is negative 1, y will be 4. When x is equal to 0, y will be 2. When x is equal to 1, y will be 1. And last, when x is equal to 2, y will be 1/2. To find all those values, I would use your calculator, and again, make sure to follow order of operations. The first thing you need to do is the 1/2 raised to whatever power you're using, and then multiply by 2, okay? In order of operations, exponents come before multiplication. So, we have our ordered pairs here. We have negative 2, 8. I'm going to go ahead and write these out. Negative 2, 8. We have negative 1, 4. We have 0, 2. we have 1, 1, and we have 2, 1/2. Let's go ahead and graph those ordered pairs. So negative 2, 8, negative 2, up to 8. Negative 1, 4. 0, 2. 1, 1. And 2, 1/2. So 2, 1/2. Now, if we if we connect all these with a curve, it'll look something like this. And again, remember, it doesn't cross our x-axis. It just gets infinitely close. So we want our curve to trail off along that x-axis. Okay? If this x-axis were to be continued out like this, our curve would just go right along it. And that's how we graph that exponential function. Notice that the graph has a y-intercept of 2 in this case. That's because we multiplied by 2. And then it gets closer to the positive side of the x-axis. As the x values increase. So again, we made our table of values. We used the same table of values, we used the same x values for our table of values, negative 2, negative 1, 0, 1, and 2. Plug that into our function, get our y value, write your ordered pairs, and graph them. Now, the rest of this section has to deal with domain and range of these functions, which we are going to skip for now. We will visit those again when we get back into school later on. But if you want to, ask Miss G about her smush theorem. We talked a little bit about that on a different section. I don't remember exactly which one. But Miss G would be happy to explain her smush theorem. Again, we'll revisit this again down the road. Make sure to get your homework done, and that's it. Have a great day.